In this video I'm going to prove that an angle in a semicircle is a right angle, and I'm going to use vector properties to do it because we've already proved it in some of our congruence and other proofs, but this time with vector properties. So here's my angle, any angle on the circumference in a semicircle. Let's label those points as A, B, C. And for this we're also going to add in, so let's let O be the center of the circle, of which this is a semicircle. And so let's actually add in also a vector from O to B. So we're going to call these here little a, as we typically do with position vectors. So we're letting OA be A, OB and OC, and some of the results that is going to lead to, which are significant to us, so maybe let's just note what that means. So note that C, for example, is just the negative of A, isn't it? Because they're both the same length, they're both from the center to the circumference or radius length, and they're just opposite in direction. And also, let's note that each of these have the same magnitudes because they're all just one radius length, aren't they? Alright, so if we're trying to show anything is perpendicular, right angles, so on with vectors, then we should be thinking dot product. So let's take the dot product of AB and BC and see what we can come up with. So AB is going to be position vector B minus position vector A, and BC is going to be C minus B. So we know that just from any vector joining 2 points. So what do we get when we expand this all out? We get B dot C minus B dot B minus A dot C, and then plus A dot B. Alright, so let's make the substitution that C is the negative of vector A. So I'm going to get the negative of B dot A here by replacing C with negative A. Then I'm going to get minus the magnitude of vector B squared. For this one here I'm going to get plus A dot A when I replace C with negative A, and then I'm going to have A dot B. Now remembering that the dot product is commutative, that means B dot A and A dot B are equal, so because this is the negative of B dot A plus A dot B, they are going to be equal, so they'll cancel each other out. So I'm left with minus the magnitude of B squared plus A dot A, which is the magnitude of A squared. And because A and B both have the same magnitude, because they're both radius lengths, the negative of one plus the other is going to be 0. Therefore, if their dot product is 0, they must be perpendicular. And so I've proven that the angle there in a semicircle is a right angle.